So we'll talk about recording methods here. Now, what are recording methods? And before that, what is recording? So as we have already discussed in our previous topic that when two coherent light beams A and B incident on a photographic plate with different angles, then due to interference, these light beams create a hologram or an interference pattern on the photographic plate. So imposing the interference pattern on the photographic plate is called recording. So hologram is get recorded with the help of this process. And there are two methods of recording. First is wavefront division technique and second is amplitude division technique. So we'll talk about wavefront division technique first. Now we'll have a look on the diagram. In this diagram, we can see that expanded coherent laser beam. This is the expanded coherent laser beam is which is obtained from laser, right? And this expanded coherent beam will strike the we are sending this expanded laser beam from here and we can see that half part of the extended laser beam is striking the mirror and the mirror will reflect back those beams here, right? And half part of the expanded laser beam, this part is going to the object, given object. So half part of the expanded laser beam is striking the mirror and it is reflecting back towards the photographic plate, and half part of the expanded laser beam is reaching till the object and it will strike the object. Now we can see laser beam which is coming back from the mirror has a plane wavefront. So this is the plane wavefront, and laser beam which is coming back after striking the given object is spherical wavefront in terms of spherical wavefront because our object is spherical. So when this wavefront, plane wavefront and spherical wavefront. So these beams are called reference beams. Reference beam which has plane wavefront, and this beam is object beam. So now we will consider these two as beam A and beam B, and interference will occur between these two and it will happen here. So this is the photographic plate, and on this photographic plate hologram will get recorded, and that hologram is nothing but interference pattern which will be like this. So this kind of pattern we'll get on the photographic pattern, and this is known as Garber zone plate. So this was about wavefront division technique. Now amplitude division technique. In this technique also we'll use expanded laser beam. So this is the expanded laser beam which we are sending from here. We are sending expanded laser beam from here and it will strike the beam splitter, and we can see that this beam splitter has property to refract and to transmit both. So some part of the beam it will transmit and some part of the beam will get refracted. Now one part of the beam will strike the mirror and it will reflect towards the photographic plate, and the another part from the beam splitter will strike the object. Again, this is the plane wavefront and this is the spherical wavefront. This is reference beam and this is object beam. So we'll consider this as A and this as B, and they will interfere and they'll create a pattern on photographic plate. So that pattern is nothing but hologram. Now we'll have to reconstruct that pattern from the photographic plate with the help of reconstruction process. So same way, so if we'll closely have a look on this diagram, and after this diagram if we'll see this diagram, so this is the laser beam, this is the hologram, laser beam is striking the hologram, these lines are virtual, this object is also virtual, and some part of the laser beam will get transmitted, and here we can see the real image of the object. So this is how we can reconstruct the real image of the object. So this is all about holographs. Thank you.